All right, William, can you hear me okay?
Yeah, we can hear you.
Great. All right, let's get rolling then. Good morning, everybody. I hope that you are having a good week. We are almost to the weekend. We're sort of in the end of October craziness of the semester. Everything is always a little bit crazy this time of year. So hopefully, you're doing some self-care and finding some time to get some rest and some fresh air. But hopefully, things are going okay. But if not, definitely be in touch with me, be in touch with the other instructors. And we will, do whatever we can to make sure that we can support you. And so just a few reminders. So later today, William will be doing his review. The link is up on Moodle, and he will be going over all the derivative techniques we've been learning in chapter 3. This is a really good practice for our midterm. That's on Monday, not our midterm, our chapter 3 quiz. That's on Monday. So if you have the ability to do that, hop onto Zoom. You can definitely try out the problems ahead of time. They are listed under the chapter 3 heading on Moodle. So just getting prepared for that. So chapter 3 is really all about these derivative techniques, and we are going to be using them to do applications in chapter 4. So it's really important that you understand all of these techniques pretty well. And if you do that, you'll do well in the chapter 3 quiz, but that will also set you up for success in chapter 4, where we are then going to use the derivatives that we find as a first step to talk about different things that are happening within our functions. So again, just really making sure that you're working through these. If you have questions from any of the quizzes or about any of the algebra, definitely stop by Drop In Help before Monday. There's times today, there's times tomorrow, there's times on Sunday. So get the help you need before Monday, and then hopefully the chapter quiz on Monday will go really well. So I think that's it for announcements. I can't think of anything else. So let's just talk about what we're going to get into today. So we are going to learn our last technique today. So last class, we were talking about the product rule, where we looked at what happens when we have two functions multiplied together and how we approach the derivative of that. Today, we are doing sort of the cousin of the product rule called the quotient rule. So I'm going to go ahead and switch over to the dot cam. Whoop. Okay, so the quotient rule comes up when we are looking at functions that are written as quotients. So what does that word quotient mean? So quotients are when you have one thing over another. So for example, if we talk about the fraction 1/4, that's a quotient, 1/4. This also happens with functions. So if you have one function over another, we call it a quotient. So that is the form that we are going to be looking for to know that we are going to be doing the quotient rule, right? So we have one function over another one. And so what the quotient rule says that we're going to do, our formula here, is the derivative of f times g minus the derivative of g times f, all divided by g of x squared. So our formula looks like this. You may also see this written in shorthand, f prime g minus g prime f, all divided by g squared. This means the same thing, right? F and g are functions of x. We're just sort of shorthanding it. But one of the things that's really important here that's different from the product rule. So in the product rule I mentioned, it does not matter which function you pick to be f and which function you pick to be g, because it'll still work out for the product rule. But for the quotient rule, it does matter. So when we set up our formula, we have to have it so that our top function is f and our bottom function is g. And the reason that that's true for the quotient rule is notice here that we're doing things like subtraction and division, which means you can't switch them, right? So like 5 minus 3 is not the same as 3 minus 5. So because we can't manipulate things that way, we have to choose these in this order, where your top function is always your f and your bottom function is always your g. Okay, so that's really important. That's different than the product rule, where it doesn't matter how we choose them. So let's see how this formula works and how we apply it. When I printed out my notes last night, I didn't realize how small the print was. So I will write this bigger so we can see it a little bit better. So the first function we're going to look at may look a little familiar to you. So we have e to the x over x to the fifth. So remember, at the end of last class, we actually did this derivative as a product rule. So we had this function and I said, how can we rewrite this to make this into a product rule? And we brought the x to the fifth up by making it x to the negative 5. Well, we don't have to do it as a product rule. We can also do it as a quotient rule, right? So when you have one function over another, we typically go for a quotient rule, but you can always rewrite quotient rules into product rules if you need to for whatever reason. So if we're going to walk through the process of this, we are going to start by calling our top function f. My top function here is e to the x. And then my bottom function is going to be g. So that's x to the fifth. From there, we're going to find each of their respective derivatives. So this map over here of how we're doing this should look familiar. This looks exactly the same as when we were doing the product rule, right? We picked our f and our g. Same thing here. We pick our f and our g, and then we find derivatives. So the derivative of e to the x is e to the x. The derivative of x to the fifth is going to give me 5x to the fourth. Okay, so once we have all our pieces, we can put it all together into the quotient rule here to get our derivative. So the quotient rule says we're going to do f prime times g. So as we talked about before, typically we write polynomial terms first. So we're multiplying these two together. So the order doesn't matter in terms of multiplication. 1 times 2 is the same as 2 times 1. But this has to be the first term. So I'm going to write this as x to the fifth times e to the x. And then minus, and so we're subtracting off g prime times f. So again, the minus is important. So g prime times f is going to give me 5x to the fourth times e to the x. And that is all divided by g squared. So I look at what my g function was. It's x to the fifth. So it'll be x to the fifth squared. And so the convention when we do the quotient rule is that whatever's in the bottom, we don't usually simplify this. So whatever the g function is, we put that in parentheses and say squared. We could certainly write this as x to the 10th because the fifth power to the second power would give you 10, but we typically don't. We usually leave it as x to the fifth squared. There's a lot of simplification we could do here. We're not going to do a whole lot of it because I want you to get used to the quotient rule. But once we get into chapter 4, we will be doing a bit of simplification. So if you want to practice that now, you can certainly, write all the ways you could simplify this underneath just for practice. Okay, so this is what we get when we take the derivative of e to the x over x to the fifth using the quotient rule. And if you compare that to what we got when we did the product rule, you'll see that it doesn't look quite the same. And so in order to get them to match, we would have to simplify this to get them to match up. Okay, but we could certainly do it. And, it would be interesting to see the algebra to go between them. So I'm going to have you try one. Now that we sort of have the idea down, I'm going to write it a little bit bigger. So here we have sine x over the natural log of x is our function. So again, we recognize that it's a quotient rule because we have one function over another one like this. So that's how we know we're going to use the quotient rule. So you're going to figure out what's your f, what's your g, find each of their respective derivatives, and then put it all back together in the formula. Okay, so I'll give you about 2.5 minutes, try it out, and then we'll go through it together. All right, take about 30 more seconds. All right. So again, we notice a quotient. We have one function over another. We pick our top function to be our f. So here, that's going to be the sine x. And our bottom function is our g, the ln x. Then from there, we want to take each of their respective derivatives. The derivative of sine is going to be cosine. And the derivative of the natural log of x is going to be 1 over x. So now we have all the pieces, and we can put them back together in the quotient rule here. So we're going to do f prime times g. So we have cosine x times ln x minus g prime times f. So 1 over x times sine x, all divided by g squared. So again, for the bottom, we usually write whatever the function is in parentheses and then squared. Okay, so our derivative looks like this. There's no simplification that we're going to do here. So this is what the final answer would look like. Okay, so now that we have, a little tiny bit of practice with the quotient rule, we can do sort of all the standard things we've been doing with derivatives. So we'll start with, our general application, which is find the equation of the tangent line, right? I'm sure that you guys guessed that was probably coming next. So again, the process is the same, where we're going to need a point, we're going to need a slope. I'll write the function a little bit bigger, right? But the difference is when we take the derivative, we're using a quotient rule because of the function we have. So the natural log of x plus 2, all divided by x cubed, is our function. And we're interested in what's happening at x equals 1, right? So we're going to use what we know now about the quotient rule, pair it with what we know about finding the equation of the tangent line, and trying to put it all together. Okay, so take about 2.5 minutes, see what you can figure out here. Remember, we need a point, we need the slope, and then we need to put it all together in y equals mx plus b. So try that out, and then we'll go through it together. All right, take about 30 more seconds. All right, so as per usual, we need to find a point to work with. So I'm going to start with that. We have half of the point here. We have the x value. To get the corresponding y value, we need to plug this into the function. So here we get the natural log of 1 plus 2, all divided by 1 cubed. The natural log of 1 is going to be 0. So we have 0 plus 2 divided by 1 is going to give me a y value of 2. So that means that the point that we're working with is 1, 2. So now we also need our slope. So this is where our quotient rule comes in. To get the slope, we need the derivative, and then we need to figure out the derivative at 1. So in order to do the derivative, we need to do a quotient rule because I have one function over another one. My top function is going to be my f. My bottom function is the g. Then I want to find each of their respective derivatives. For f, the derivative of the ln of x is 1 over x, and the derivative of 2 is 0, because that's a constant that's by itself. The derivative of x cubed is 3x squared. So putting that together into our quotient rule, we're going to have f prime times g. So we have 1 over x times x cubed minus g prime times f. So 3x squared times, now f has more than one term, so I'm going to use parentheses, ln of x plus 2, all divided by g squared. So x cubed squared. So we need to plug a 1 into this function. It's up to you whether or not you want to simplify before you plug in the 1, or you can just plug in the 1 as is. You'll get the same answer either way. It's just a matter of preference. So when I go ahead and plug in 1, I'm going to get 1 times 1. So I have 1 minus 3 times 1 squared, which is 1, times, and now my parentheses, the natural log of 1 is 0 plus 2, gives me 2, all divided by 1 cubed, which is 1, and then squared, which is still 1. So I had to crunch this number. So I have 1 minus 6 divided by 1. That's going to give me -5. I don't know why my negative got lost here. So my slope is -5. So now I have a point and I have a slope. So I need to put that together to find my b. I don't have enough space, so I have some blank paper here to write on. So what's going to happen here? I have y equals -5x plus b. I'm going to use my point here when x equals 1, y equals 2. So I have 2 equals -5 times 1 plus b. So to get b, I need to add the 5 over. And I get b equals 7. So putting that all together, I get y equals -5x plus 7. So again, whenever I'm looking for the equation of a tangent line, this process is always the same. And what's changing is the function. So no matter what type of function we give you, you're always finding the point, and then you use the derivative to find the slope, and then you have to put it all together. So that's what we have to do here. And this is the equation of our tangent line from doing that. Okay. So for the next problem, we're going to look at first and second derivatives. So I'm going to write this a little bit bigger because, again, I printed it too small. So we have x to the fourth over sine x. So when you find the first derivative of this function, you're using the quotient rule and you're using it in the way we've been using it, the last couple problems. And that part is, I won't call it straightforward, but that part is just doing what we've been doing. When you go from the first derivative to the second derivative, however, you're still going to have to do a quotient rule, but within that, you are also going to have to do a chain rule and two product rules. So the second derivative is a bit more complex, that uses a lot more of the ideas, but as long as you're really careful and you write everything out, then I think you can do it. Okay, so I'm going to give you about 5 minutes on this one because the second derivative is a bit tricky. Try it out, see what you can figure out, just do the best you can, and then we'll go through it together. right, take about 30 more seconds. All right. So for our first derivative, we're following the same thing that we've been doing before. Our top function will be our f, and our bottom function will be our g. Then we need to find each of their respective derivatives. So the derivative of x to the fourth is 4x cubed. We use the power rule there. The derivative of sine is cosine. So our first derivative, using this quotient rule, we're going to do f prime times g. So we have 4x cubed times sine x minus g prime f. So minus cosine x times x to the fourth, all divided by g squared. So we have sine x squared. So hopefully that felt okay based on the work we've been doing. But now in order to get to the second derivative, we need to look at this and figure out how to take the derivative. And so we have to do yet another quotient rule where the pieces are a little more complicated, right? So our f, which is our top function, is now going to be 4x cubed times sine x minus cosine x times x to the fourth. And our g function will be the bottom, which is sine of x squared. Okay, so this is the part where things get really quite tricky because we have to think back to all the things we've been doing before. I'm actually going to start with g. So g prime here, we're going to have to do a chain rule. So we have parentheses raised to a power. So this is in our power form. And so when we take the derivative, we can do the power first. So the 2 comes down. Everything inside stays the same. We subtract 1 from the power. So that's the outside part of this. But we have to multiply this by the derivative of the inside. So the derivative of sine is going to be cosine. So we end up with 2 times sine times cosine. We don't have to write the 1 power. It's one of those implied things. Now over here, let's think about this in 2 pieces. Okay, so the first piece that is separated by subtraction here, the first part is 4x cubed times sine x. Okay, so notice here I have 2 functions that are multiplied together that both have the x. That means that I have to do a product rule to get the derivative of this first term. Okay, so when I do the product rule, I again have to split up my 2 functions. So my f will be 4x cubed. My g will be sine x, right? So this is my f, this is my g for the product rule. The derivative of 4x cubed will be 12x squared. The derivative of sine will be cosine. And now, when I use the product rule to put these back together, I have f prime times g plus g prime times f. So remember, again, this is just the derivative for this piece of the quotient rule. So f prime times g is going to give me 12x squared times sine x plus g prime times f. So cosine x times 4x cubed. Now I have to do minus, and what I need to subtract off is the derivative of this second term. And so the second term also needs a product rule of its own. So here for the second term, I have a cosine x, and I have an x to the fourth. Notice that I didn't write the minus because I put the minus down here, and then I'm going to do parentheses to multiply these through. So the derivative of cosine is negative sine. The derivative of x to the fourth is 4x cubed. Okay, so again, product rule, f prime times g. So I have negative x to the fourth sine x. Again, I just pulled this term to the front. That's the convention. Plus g prime times f. So plus 4x cubed times cosine x. Okay. So again, all of that work was just to find our f prime and our g prime, and we still need to put that all together into the quotient rule to get our final second derivative. So as you can imagine, this is going to be fairly long. So I'm trying to think about how I can get this all in one place. Here, give me a second here. So I'm going to kind of put, we need our f prime, our g, and our g prime. But I want to write diagonally to fit everything. Okay, so I'm going to start by writing down my f prime because my first step is f prime times g. Okay, so for my f prime, I have 12x squared times sine x plus cosine x times 4x cubed minus negative x to the fourth sine x plus 4x cubed cosine x. I'm kind of writing diagonal just because this is so long. So this was my f prime times g, right? So now I go back up here. What was my g? Well, my g was sine of x squared minus g prime times f. So g prime is 2 sine x cosine x times f. So there's more than one term, so I'm going to use parentheses. This is completely curved just because I don't have enough space on a board to show you guys. So times f. So we have 4x cubed sine x minus cosine x times x to the fourth. This ended up being super round. Okay, so this is the whole numerator, right? Normally, if I was on the board, I would just do the whole entire board. Didn't have enough space. But this was f prime times g minus g prime times f. So those are all the terms that we found over here, right? So that's our g prime times f. You can check all those terms as you're writing them there. And then we have to divide that by g squared. So we have sine x. So it was sine x squared squared. So we would write that all to the fourth power, right? So again, f prime, super long, super crazy, times g, right? That was our g term, minus, then this is our g prime term, times f, which was this term, which was the original f term, all divided by g squared, okay? And those are all the pieces. So here's all the pieces that we use to put that together. So that being said, sometimes your first derivative can be something that is fairly straightforward in application, but when you try to go from a first to second derivative, you have to use other techniques than the one you were thinking of. You could start with a chain rule function for a first derivative and end up doing a quotient rule for the second derivative. So when you go from a first derivative to a second derivative, you really need to look at all the parts of the first derivative to figure out what other rules might have come out as a result of finding the first derivative. Okay, now obviously this one is very long and it's sort of time consuming, and this is definitely on the difficult end of the spectrum of quotient rules because it uses quotients and chains and products. Oh my, right? So you wouldn't necessarily need to do one of these on a quiz, but on homework, you may have something that is a bit longer than your typical first derivative quotient rule. Okay. That being said, we can also look at an example where we do have to do something with chain rules or something a little more difficult that is not quite as extensive as this particular problem. So let's go ahead and look at this next problem where we are looking for a derivative, and within this, we will see that we need to do some chain rules. So let me write this a little bit bigger. Okay, see that? So sine. Papers everywhere. Let me just get organized for a second. So we have sine of x cubed plus 2x minus 1 divided by e to the 5x cubed. Okay, so looking at this particular problem, the outside structure that we see here is a quotient rule. We have one function over another one. But what we notice is that within these individual functions, when we try to take the derivatives, we are going to have to use chain rules, right? So you're going to start this off as a quotient rule problem, and then within finding your f and your g, you will use chain rules to find their respective derivatives. Okay, so I'm going to give you about 3 minutes to try this one out. Write everything down really carefully, write down all your steps, and then compose it back together within the quotient rule. Okay, so take about 3 minutes, and then we'll go through it together. All right, take about 30 more seconds. All right, so let's walk through this one. So again, we're starting with our quotient rule setup here. We're going to pick our top function to be f. So sine of x cubed plus 2x minus 1. And our bottom function is g, which is e to the 5x cubed. Now we need to find each of their respective derivatives. So this is where our chain rules come in. So again, for sine and cosine, we start by doing the outermost function. So the derivative of sine is cosine. When we do the cosine, everything inside stays the same. But we have to remember to multiply that by the derivative of the inside, right? So here the derivative of x cubed is 3x squared. The derivative of 2x is 2, and the derivative of 1 is 0. Over here, for our e term, we see that this is in the exponential form, and our chain rule for exponentials, particularly e's, is that we're going to get the same thing back, e to the 5x cubed, times the derivative of the power. So the derivative of the power here is 15x squared. So now that we have all our pieces, we want to plug this into the quotient rule. So we're going to do f prime times g. Okay, so we have cosine of x cubed plus 2x minus 1 times 3x squared plus 2. That's our f prime times g. So e to the 5x cubed. So that's our first part, minus g prime times f. So e to the 5x cubed times 15x squared. That's our g prime times f, which is sine of x cubed plus 2x minus 1. All of that divided by g squared. So again, I'm going to put my g function in parentheses. So e to the 5x cubed squared. So one thing I want to mention here is that we talked about how sometimes we reorder things. And so as these functions get more complicated, I strongly want you to encourage you to think about looking this in terms of factors. So like in this first term, there's 3 factors. There's the cosine, there's the 3x squared plus 2, and there's e to the 5x cubed. You're going to check that against a possible answer that's on Moodle or wherever you're looking, and you're going to say, okay, is the cosine term there? Yes. Is the 3x squared plus 2 term there? Yes. Is the e term there? Yes. It doesn't matter if they're in a different order. You're matching them to the first term of the answer. And then you'll go to the second part, which is what we're subtracting off, and you'll do the same thing. And you'll check everything after the minus sign, right? And you'll kind of go and make sure all 3 of those terms are in the answer that you're looking for, because if they're not, then you can consider eliminating it. And then of course, you'll check the denominator to see if that matches, right? So instead of worrying about reordering or factoring, if you just check all the terms to make sure they match, that's a good way to make sure that however order you wrote it, right, whether you had the e at the front or at the end, that it's the same answer, okay? So that's our last problem for today. We're going to stop here. I want to make sure you have time to just rest and be outside and not be stressed. Again, I encourage you to do the homework before you take the mini quiz so that you get a lot of practice on the algebra and the structure of these types of problems. Don't forget about the Chapter 3 quiz on Monday. And otherwise, I will see you guys all on Tuesday.